Thank you all for attending. My name is Jason Bock. I'm a developer advocate at Quicken Loans. And my talk in this session is called What's New in C# 9? So that's a little bit of information about myself. If you have questions during the talk, just interrupt me, just come off of mute and say, hey, Jason, I got a question, and I'll try to answer it as best as I can. If you have a question that comes up afterwards, feel free to email me at jason.r.bock@outlook.com. I'm going to have two repositories that I'm going to be using for demos. Most of this talk is going to be code demos, and most of the code is actually in that first repository. The second one is a quick demo on source generators, and if you want the slides so you can get all of these links, really remember that last one, jasonbox/presentations. I have the slide deck for this presentation along with others I've done, so go and check those out. These links will be on the next slide as well as the last one, so if you didn't catch them, you'll see them on those as well. All right, so I'm going to spend just a little bit of time talking about language evolution in C#. Most of the time we'll be going through the new C# 9 features, and then we'll spend a little time at the end talking about where C# is going to be going in the future. All right, so C# is a language that's been around for quite some time. In fact, it was funny, my older son and I were driving to self-defense lessons this morning, and he's taking a web development class in high school this semester. And we were just started talking about JavaScript and programming languages, and he asked me, well, what's your primary language? And I said, C#. I've been doing it for almost 20 years. And this is indicative of that. I got onto the C#.NET bandwagon, so to speak, way back even before this, when there were these rumors of a Java-like language brewing within the Microsoft world. So my primary language has been C#, and I'm always a big advocate for people learning other languages and picking up other things that languages do that are really cool. But at the same time, I have to admit, I feel the most proficient in this language, primarily because I've spent so much time in it. Okay? Just to go through the features really quick that's happened throughout its history. The first version has a lot of object-oriented features that you would expect from a language that's primarily object-oriented, although that changes over time. The second version, the biggest one, was generics. If you can actually think of a time for about 3 years, there were no generics in C#, and that was quite painful. So having generics allowed C# developers to be a lot more expressive and safe with how they were coding things in the language. Version 3 brought LINQ and a lot of features that came along with it, like implicitly typed local variables, var. And I'm going to just jump out real quick. I know we have a short amount of time, but I have to show this. Have to show this because it is so much fun. I can put this anywhere. Okay, let's just do this. Public static class var. Now, what just happened? The funny thing with var here is it wasn't a reserved keyword. So what I've now done is made var a name of a type, a class. So you can't use var anywhere in the code anymore. Okay? Please don't do this. This is really, really evil. Don't do this. But it's just funny because if you really don't like var for whatever reason, actually put that in your editor config and configure it that way. Don't do that little trick. But it's a fun one to play on people. So there were a lot of features that were added for LINQ, like var, anonymous types, expression trees, and so on. 4 didn't really have a lot of things that people use, I think, on a day-to-day basis, either explicitly or even implicitly. 5 had asynchronous methods and caller info attributes. Async, in a way, was a rather large feature, so that took up a fair amount of time. But while this was all happening within Microsoft and the C# team, and really the .NET team, is that they were building this whole new compiler infrastructure, which was originally called Project Roslyn and is now known as the Compiler API, or the .NET Compiler Platform. Essentially, it's this open API that people can use to find out all sorts of information that you would get from a compiler and be able to do whatever you really want with it. That's what the compiler itself now is based, so C# compiles C#. And you can actually do this contribution yourself. If you go to this link, if you've been noticing in my slides on the lower right, I have links to things that are pertinent to what you see on that slide. This is a snapshot of the contributors to C#. And as you would expect, those people there actually work at Microsoft. But if you scroll down, you will see people there that are outside of the walls of Microsoft and are contributing to the language in both large and small ways. If you want to contribute yourself, you can go to the link you see at the bottom right and filter essentially for label community. These are issues that have already been curated by the team to say, we can give these to people outside the community. They're not that complicated, and that gives people the ability to start jumping in and doing these PRs, to start helping out, and then to have the ability to say, I actually helped on the C# team and on the language, and I was able to contribute to that. And that's a very powerful, cool thing. Okay. So in version 6, that's when it switched to being targeting the Project Roslyn compiler API. And one thing I've noticed since 6 and beyond is that we're getting a lot of smaller-ish features that are actually fairly powerful and nice to have. And it's cool that the time to change and to evolve and to give feedback on these issues is getting less and less, which is a really good thing. During the C# beta cycle, there are actually other features that were put in that were pulled out. One, I think, was actually pulled out just a couple days before they released, something to that effect. And that may sound like a lot of churn, but that gives people that are outside of the team to provide feedback, say, hey, this feature doesn't quite work, the way you might think it's supposed to work, or hey, I ran into this issue, and then they can start to adjust and react accordingly. Okay. Version 7 actually did something where they played with this idea called point releases. So not only did you have a version 7, but you had a version 7.1 where one of the things you could do now is an async main. So you can actually make your main method async. 7.2 and also 7.3. Then we had version 8. Version 8 was interesting because it was the first version where you started to see this bifurcation between the .NET framework, big F, and the one that runs on Windows and Windows only, and .NET Core, or now it's .NET 5. Version 8, particularly default interface members, not just methods, but members, will only work in .NET Core and beyond. In fact, this picture that I saw somebody tweet around this time started to show you what are some things that don't work, at least directly out of the box. Maybe you have to kind of put in some shim types to fool the compiler to think it's going to work. Default interface implementations will never work in .NET Framework 4.8, and over time, that difference is just going to get larger and larger as everything is now converged onto .NET 5 and beyond. And that is the same thing with version 9. As you can see, there's a lot of features. Some are very small, and as I do demos on this stuff, I'm going to spend time more on some features than others. Some I'm just going to at least just show you, and that's it, because they're very, very small. But keep in mind, with every feature that's ever added in the C#, and this may sound like marketing, but as long as I've been following the language and also being an MVP and having the ability to talk to people on the team, and it's really been eye-opening to see how this language evolves from their side as well, that every feature that's added, even if it looks small or it's not one that people would use for the most part, there's definitely a lot of discussion, arguments, and so on that goes around adding a feature because there's a cost involved, and it's going to stick for a long time. By long, I mean they don't want to break backwards compatibility. So adding features is not taken lightly. And if you look at a feature and go, yeah, I don't think I'm ever going to use that, like function pointers, I'm going to show you what that is. You might look at that and go, I don't ever see myself ever using that. And that's a totally fair statement. But there are people that have been asking for that kind of feature, and having this now native into C# helps them do some things that they need to do in their applications. Okay, so enough of the history. Let's actually dive into C# 9 features. So I'm just going to check and see if I'm getting any. Wouldn't custom var have its own namespace? Oh, so in that case, with the horrible code I just showed with public static class var, that's actually in what's called the global namespace. So long story short, exists everywhere within your application. So if you want a class that doesn't have a namespace, you just don't have to put it in a namespace. And then there is a global namespace that exists for everything. In fact, if you do stuff with like reflection, you'll sometimes, or even in the compiler API, you will see things called global namespace. And that's essentially what everything's put in. And then if you put in namespaces, that's added after the global namespace. Most people, it doesn't matter and they don't care, and rightfully so. I don't ever define classes outside of a namespace, but that's how that works, okay? You can put it into system. You can do like namespace system, because pretty much everybody puts in using system in their code files virtually all the time, so that would work as well. But that's how that works. Okay, so I'm going to go into Visual Studio here, and I'm actually going to close this file first. And to just explain what I'm doing here, I've done this talk now for C# 6, 7, 8, and now 9. And the way I do it is I just have a console app, and then I've got a method that represents each feature. So we're just going to uncomment and comment code out so we can take a look at each one. But the reason I don't want to show you this code just yet is just by opening the program file, I'm going to show you a feature that was added into C# 9. Okay, and just to also show you, this is what the CS_proj file looks like. Just in case you don't know, there are these things called SDK style project files that have been around now since essentially .NET Core, and you can edit them in Visual Studio. I have not edited a CS_proj file from like the project properties, and I don't remember anymore. I do everything within the project file itself. It's so much easier, so much cleaner, so much better. Okay, so you can see here I'm targeting .NET 5.0, and also the Lang version I have is 9.0. I also have a nullable enabled. That's been there since C# 8 with nullable reference types, and I highly recommend for any new code that you have enable turned on, or nullable turned on with enable. Okay. Well, let's actually open the program file here. You may look at this at first and go, where is my program class and where is my main method? You're looking at it. Yeah. This is what's called top level statements. So you no longer need, you can still declare a program class, you can still declare a main method, all of that is fine, but you don't have to. You can just get rid of all that. In fact, let me just push all this code down here. You could have a program CS file that just did this, system.console.writeline hello world. Okay, now you're seeing some red squiggles below, and that's fine because we've now got some mistakes. But the point is, you could have a one-liner to do hello world now in C#. And part of the reason they're doing this is they're starting to look at how can we make our code a little bit more terse, a little bit less verbose, a little bit less ceremony. One of the features that was added in C#, I think this was in 7, or one of the point releases, I'm not sure, but it was where you can say using var C equals new connection or whatever, and it was something that was disposable, and you didn't have to have a block or the curly braces around the piece of code that essentially once all that went away or it was done, dispose would be called. It now has this implicit block that basically says everything below it until you get to an outer scope. That's what's considered to be in that code that will run, and then dispose gets called. So they're doing more things like this. And at first when I saw this, I was like, what in the world is going on? Why would you even need this or do this? The more I've used it though, the more I like it. I really think it's a small but very nice feature to keep code a little bit cleaner. If you still want to use the arguments, you'll notice here that I could have like var c is equal to args, and that's actually a string array. Okay, those are the arguments that get passed in to your application. So that still exists. If you really are interested to see what C# does with all this code, use a tool like ILSpy, which is a decompiler. I love that tool. It's really, really nice if you ever want to just look at what's actually compiled into your code or into your executable. And then you'll see what it does is this kind of name mangling thing to get all of your methods and other types into, the assembly, and essentially wrap this all within a main method so that it just works. But you don't have to do this. You can only have one class, though, that has these top-level statements, again, where you have using statements, and then you start defining a method or something like that, or just you have code there. The compiler will pick that up and say, you have just a statement here, a top level statement. This is where you're actually going to have your main method, and it starts interpreting your code to compile it as such. If you try doing this in 2 or more files or 2 or more places, you'll get an error and it won't work. So typically you would just do this in your program CS file. Again, I highly recommend starting to use this. I find this it makes it a little bit easier and cleaner to get the main stuff started, so to speak. Okay. All right, let's look at records. This is a feature that's gotten a lot of press. I've seen people within Microsoft and also from the community talking about this. I think this is probably the feature that's gotten the most press, and it's called records. Okay. So by the way, notice that on each method, I also have a link to where you can find more information about that feature from the documentation on docs.microsoft.com. Okay. So demonstrate records here. At first, this code probably looks very similar. Nothing, in fact, if you look at this, probably nothing looks very different than what you're used to. I have a new customer here, I print it out, which means I'm calling toString. But typically when I call toString on an object, unless they've overridden it, doesn't have a lot of information. So I probably will write something like this, so I can see all the age and the name. But notice I have something commented out here which says this won't work. If I actually uncomment this, you'll notice that the age should get a squiggle, and it does, because it's saying, well, I can't assign to age here. Okay, so what's going on with customer? Okay, well, I could have just made it a getter. That's fine. But if I actually look at the customer class here, well, it's actually defined as a record. Okay, and this is about the shortest way to define a record if you would like to. Okay, what this essentially does is it creates a class for you. And just classes. There's no way to make a record that's based off of a struct, though that's already been proposed to do potentially in the future. But right now, records are really just classes, and they are read-only classes by default. Okay. And the way I can define properties is, if you look down, you'll see one where you can actually declare the properties yourself, or you can use this kind of like constructor syntax, where these things being passed in are actually going to be turned into properties for me. Okay, so this looks a little weird because typically parameters to methods are camel cased in .NET, or at least in C#. That's the usual convention you see. Usually don't do it this way, but the reason why is because these will end up actually being the property names for customer. So that's why I'm using Pascal case here. Okay. So you can inherit from records from other records. So I could have an identified customer or a valued customer as well, which they have their own properties. You can't have classes inherit from records. And the reason why is because there's a whole bunch of code that's generated for any record that gives it the ability to do deconstruction, equality, comparison, and so on. Okay, and it's something that if you inherit a class from that record, it may start to break some of these expected contracts or behaviors. So that's not allowed. Once you create a record, you cannot have it. You can't have classes inherit from that record. Okay. So if we go back to our code here, let me actually run it so you can kind of see what happens. And here so we can see it. You'll see here that when I print out the customer, we actually get a very nice toString format, and that's provided by the record syntax. The toString is automatically created to do this format where it gets all the values of the properties. Okay. If I want to deconstruct the customer using that age name syntax there, that also works. That's out of the box for you. I can also use something called withers. So you'll notice down here that our customer with different name is being created from the customer with the name being equal to Joe. Okay, so this is a little weird because records by default are immutable. As you saw here, I wasn't able to change the age, but it's a very natural syntax to want to be able to say, well, I want to create something from this original target, but I just want to change this value. So what records allow you to do is say, well, I want to take this original target, but then I want to change the name to Joe on the new object that I'm going to get. Okay, so that's how you use this with syntax. And so you can see here the customer with a different name. Now the name is Joe. Okay. The mutable customer, if I jump back to records here, you'll notice that with the properties, I can define them with this get and init. That's a new thing that's also been added, and that's not specific to records. You can use init anywhere you want in C#. And what init allows you to do is say, this property must be set either on construction or within an object initializer. So like you saw here before, where I want to do something where I create an object where I have that object initialization syntax. This allows you to set that property within that syntax by using the init. So a property can either have an init or a set. It can't be get, init, and set. That's not allowed. Okay? Because a set, you can set it anywhere you want. So this gives you a little bit more breathing room to say during object initialization, I want to set the value of the property, but once that's set, then it becomes read-only and you can no longer change it. You can make properties on records mutable. That's perfectly fine. Just define the property this way. And just to be clear, on records, you can define any methods you want. You can, you're not just limited to what you're seeing with the built-in toString and deconstruction support. You can put any methods you want on a record. That's totally up to you. This just gives you the basic out-of-the-box experience with the customer up there. But if I want to create a property that is mutable, I can definitely do that as well. And that's what you'll see here with mutable customer. And then now I'm allowed to change the name to Julie. Okay. If you want to see how equality is actually generated, I come back here to show you that the second customer here is equal to the customer that we created at the top, which is Jane at 22. Look at a tool like ILSpy, and you'll see how equality is automatically generated for you. So that in this case, those two distinct objects are actually considered to be equal. Okay? I'm just going to check the chat here real quick. Why do we have string question marks? String can be nullable as they are object types. So that's actually a real, thanks Mel, by the way, for the link to ILSpy. That's exactly the place you want to look. Why do we have string question marks? So in C#8, there was this feature called nullable reference types. Unfortunately, I don't have the time to get into it here, but that's where you are allowed to actually say that a reference type, you can support having it be null. If you have nullable equals to enable, like you saw in the CS proj file definition that I did, then what happens is every variable reference, every parameter that's a reference type is assumed that it cannot be null. And so you actually have to put a question mark there if you basically allow that to be null. And so that has the ability for the compiler to check cases where you might think something is a null where it could be. And so that's nice, but it also helps you really express your intent in terms of what you support and what you can actually allow for a reference type. Okay. Yeah, the discuss ways to secure CS files. There is none. It's an interesting question about obfuscation. There really is no way to secure CS files. So yeah, I could talk maybe a little bit later about that if I get done a little early. But long and short of it is anything with obfuscation, there's always somebody there that's going to find a way around it to figure out what your code did. And really, if you want obfuscation, it's not your CS file, it's your assembly, and that's what you would want to obfuscate. Okay. All right. So let's move on to the next feature, target type new. So this one, if you look at the way I've defined the customer, which typically I like var, so I wouldn't write my code this way. But what you can now do in C#9 is if you have declared what the type is, you don't have to say new customer. I can just say new, and this is exactly the same thing. There's no difference, okay? Now, you may look at this and go, well, okay, fine, but I like using var. So I could, like here, I couldn't say var wrapper equals new because C# is going to go new what? I have no idea what you're referring to. So I still have to put the type here. But one place, in fact, a couple places I've seen where this new feature I think is helpful is with field initialization. So if I dive into Wrap Dictionary here, you'll notice that fields, you have to declare the type, and if you want to initialize them, you also had to declare the type on the right-hand side as well. You don't have to do this anymore. You can do something like this, okay? So I find this to be very helpful if I have the case where I want to initialize a field. I don't have to now put the type on both sides. Okay? Furthermore, if you're passing in a value to a method, instead of saying if the method was taking a customer, I no longer have to pass in new customer. I could literally say at the call site new and then pass in the values to the customer's constructor, and then a customer gets passed into the method. Does this make things less readable? That's definitely debatable. And I've used that in some code I've written recently, and it's kind of a tension there. I'm not really sure if that helps in terms of readability or not. In part with a lot of these features that have come up with C# recently is it takes a little bit of getting used to. At least that's been my experience. And maybe it looks weird or odd or different, but at some point I start going, if I don't have these features and I code without them, I actually feel a little like something's been pulled away from me. And I realize that I actually do like them. Okay, so that's target type new, and you give that a whirl when you're creating new things. See if you can not have to put the type name there, and then kind of this debate in your head of going, is this really something that I want or not? Module initializer, let me go into this one. This is one of those cases, and again, there's going to be some features in here that I'm going to not spend a lot of time on because they're fairly short. And they're also very targeted to specific scenarios. So this module initializer, I'm going to run this first, okay? And you'll see that I get an error right away. Something about consider initializing the array. Well, what's actually going on here? So I have initialized data values sum. Okay, now I have a global values thing. It's a static data field, which I don't really like. I don't like doing that type of thing, but it's just to illustrate the point here, which is if I go to values, what's happening? This is not actually getting initialized for me right away. And so if I just assume that it's there, I run into a problem. What I really want is this initialize method to run, okay? Now, I could do something where I have a method at the beginning of my project somewhere that makes sure that everything is set up. But you can do this now in C#9, this module initializer. Okay, so what this does is if you have it in your code, you have this attribute in your code, and you can only have this attribute on one method. Otherwise, you start getting into the case of which one would run before the other one. So you can only have one method, it can't be generic, it can't return anything, and it can't take any parameters. But if you follow all those criteria, what will happen is this method will actually be invoked before anything gets invoked, including main, okay? So now that I have this method in here, what should happen when I run this is that you should see this being called first before this is actually called. Okay, so let's run this now. And what happens in this case is we do get the initialize call first, then the method that essentially was kicked off from main, and now our array is set to a valid value and everything works as expected. Okay, so this is something that I personally don't see myself ever using. I don't know if anybody else would ever be using it, but maybe in some cases you may consider, I would like this to be in place because I want to make sure that something is set up before anything else even runs, even before my main method. Okay. Let's move on to locals init. This is a really specific one. And I'm not even going to run this. I'm just going to mention that in C#, when you have variables declared, they're zero initialized, which essentially means the compiler and really runtime will set your local variables and zero them out and set them to a default value. Okay. For virtually every program that you ever write, the overhead to do that is negligible. You never even notice that that happens. But in cases where you're really, really concerned about that, especially if you're doing a lot of like unsafe stack alloc initialization and those types of things, you may not want those to be automatically zeroed out. So what you can do now is use this skip locals init attribute. And what that will do is basically say, I don't want that zero initialization to occur. All right, so if I just run that code real quick with the attribute commented out, what you'll see is a GUID is always initialized to an empty GUID, okay? But if I come back down here and turn this off, or actually turn it on, now you'll see that I get garbage in there, okay? So as long as I'm okay with that, and I would eventually set that when I need it to be, then I could put this on. So one of the questions that's come up is, should I just put this into my assembly and just say, do this for everything? Because frankly, I don't really even care. Is this going to make my code run significantly faster? No. There's an article that I reference in my slides. It's in the notes section on the last slide, where somebody's done some analysis on skip locals and init. And unless you're doing explicit stack allocation in your methods, this isn't going to help out at all. So only use it in those cases. If your program runs just fine, then you probably don't even need to use this. But if you are doing that kind of memory allocation, then this might be something you want to look at to get just that little bit extra performance. Okay. Number types, just going to mention that there are native integer types now with nint in C#, so that's native to your processor. It's if get type gets evaluated, it's actually stored as an int pointer. Okay, so again, for most code, you don't care about having native types, but if you do, that's now supported. At least that support's starting to come to C#. There's also what I found interesting, which is a half type. A half type is half of and I have to make sure I get these right because float is less than a double. It's half of one of those. So it's a 16-bit, I think, precision floating point number. Okay. So if you have cases where you want to have a floating point number, but you don't need the precision of a float or a double, you can now use a half. The only thing with a half is that it's not a native named type in C# like int, float, decimal, and so on. So you have to cast it this way for C# to understand that it's actually a half type. And if I would run these, you would see that they get truncated pretty harshly because you don't get a lot of precision with these values. But again, if you want to use that type to save on some memory, you now know that half exists. Covariant return types, again, I'm just going to check the comments here real quick. Sorry, I meant what's a good use case for using records? It's more of a new functionality rather than just a coding style. Yeah, you're right, Jeff. I jokingly put somewhere, I think it might have been Twitter, where I said that everybody should declare their classes as records. Fight me. So everything you write down in your code should just be, instead of a class, make it a record, because you get immutability, which is a nice thing by default. You get equality, you get deconstruction, you get a nice toString. Why would I not want this? Okay. Well, maybe in some cases you don't. So maybe you don't want to make everything a record. It's an open-ended question to me. The record syntax to me is really nice if you're using POCOs. You have such a very short, terse, verbose syntax that you can literally define something in one line. And so for POCOs, those are actually really, really nice. Okay, so that's one case that I've seen, but I've thought in my head, why wouldn't I use this for a lot of things that I do? So I think over time we'll learn where the best places are to use that. Can you give an example of stack allocation where skip locals and this makes sense? Again, I'll just refer to that article that I have in this. I think. Let me just see if I can dive down there real quick and find it. Yeah, skip locals and init. So let me just throw this one in there. And this person, I think, does an absolutely fantastic job of talking about skip locals and init in very, very excruciating detail. Okay, so we'll leave it at that. All right, so covariant return types in C#4, there was this notion of covariance and contravariance, and it's a little bit, it essentially just makes type systems act more natural, for lack of a better phrase. And if I get any farther than that, it starts, I think, to confuse people, especially if they haven't spent any time on those terms. But the thing I want to show here with covariant return types is the example here is, I have an API that's kind of like a Fluent API where I'm doing add identifier, add name. You've seen things like this where you call a method and it just returns the instance of what you got back before. and it might have done some things internally. And so you can chain all these methods together to do stuff in a fluent type of way. The problem is, if I go into the definition of custom pipeline, which inherits from pipeline, is, for example, if I had an add identifier here, it returns a pipeline. But in my case here with custom is I have an add name, okay? So if I start including that in my chain of fluent calls, I may have to start doing cast, and it gets a little ugly, and I don't want to do that. So what you can do now is, you notice that add identifier here returns a pipeline, is I can change it so that it actually returns a custom pipeline. That's a covariant return, and that's now supported in C#9. So I still get this nice fluent interface, and I don't have to put any casts in place, and things just work. Okay. Static anonymous methods. I'm just going to mention here that static anonymous methods have been around for quite some time. There were local functions added to C#7, and then I believe in 8, you could make a local function static, which essentially said it couldn't capture any variables or parameters outside of the method into the method itself. And in some cases, more often than not, you probably don't want to do that, because trying to capture variables and when things get executed in LINQ, it can be a little bit confusing. Okay, so if you want the function to just focus on what it's doing, you could put static on it for a local function. This now works for anonymous methods here as well. So in this case, this anonymous method isn't static, so it can capture the value outside of it. But as you can see in the commented code here, if I put static in front of it, then this would actually not be allowed. It would say that's a compiler error. So, just realize that you can now use statics on anonymous methods, and that prevents you from doing capturing of local variables. Speaking of local functions, you can also now make a local function obsolete. You couldn't do that before, but now in C#9, they've added that support, so that obsolete actually works on a local function as well. I'm going to skip the discards and lambda, excuse me. Function pointers is one of those things that's a real corner case, and it's mostly there just in those cases where you have to do a platform invocation, a p invoke, where you're calling a native method in some C-based DLL. Quite honestly, I have not done that. I can't remember the last time I've done that in C#. That's not to say other people don't. It's just in my personal experience, I used to, when I started in C#, having to declare p invokes, but I have not done that in quite some time. The thing with function pointers, if I dive in here to this class here pointing to functions, is you're going to see this kind of odd delegate pointer int void syntax. Okay, and the long and short of it is that this function pointer syntax gives you a little bit more flexibility and a little bit better performance than using something like an action. And they also can work better when you have to point to a function that you're passing into a p invoke. So you probably saw that I was using the unsafe keyword in this case, and that's true. You do need unsafe there. But again, if you are doing things where you have to pass in a function pointer, you can now use function pointers directly within C#, and that just works. Okay, I'm going to skip over that one. Partial method signatures. Again, I'm just watching my time here to make sure I had that time. Partial method signatures. Partial classes have been around since 1.0, but their functionality has been kind of limited in terms of what you could define in a partial type. So let me actually get in here to calculate. That's been expanded now in C#9, and this comes in part because of this other feature, source generators, which I am definitely going to make sure I spend a little bit of time on at the end, because to me that's the coolest feature of them all. So what you can now do in partial methods is you can declare accessibility, return types. I believe you can actually pass in parameters now. Those members and methods were very restricted as to what you could do to define them, but now it's opened up more so that you can support more scenarios and cases. And this matters because if you want to do source generators, or if you want to be able to declare different partial types in different places in your code, you're not limited anymore to a very small set of syntax for a partial method. So for example, you have more capability, more options now in terms of what that signature looks like. Okay, pattern matching enhancements. Let me dive down here again, just check to see the comments. Nothing? Okay, good. Don't take that the wrong way. I do want comments. I just want to make sure I didn't actually miss anything is what I was trying to get at. Pattern matching enhancements. This has started happening in C#7, where essentially they took the switch keyword and started to increase its capability and modernize it and make it something that's a lot more flexible. So in C#9, they've actually added a couple more things. I mean, pattern matching in and of itself is a really large feature now, and there's a lot of cool things you can do in pattern matching. What I want to show here is just some things that have been added in C#9. And one of them is this qualification, this, excuse me, this Quirkle thing. Quirkle is a board game that my wife and I play, and you can get different values based on how your turn plays out. And of course, the higher the value, the better. So I want to put them together to say, hey, if I got this value, how would I qualify that? How would I describe that move? Is that a good move or is that a bad move? Okay, so we're going to see some qualifications here. In fact, if I go back up and make sure that this is running, we'll comment it here. Okay. And no, don't run it. That's not what I wanted you to do. Stop. Cease. No, I didn't mean debug. Hit the wrong key. There we go. So let's run this now, and you'll see that I get different descriptions of these values. Okay. So what's actually going on there? I dive in the qualify here. You can see I have an enumeration that defines different descriptions of a play in Quirkle. But now if I come down here to qualify, notice I have the score switch, and then I can just basically have different conditions that if the value matches, then it will do the thing on the right. In this case, I wanted to return a qualifier value. But notice what I have here now. I have greater than or equal to 0 and less than 4. I actually have the literal and word in there. Okay, so you might say, why didn't they, if I want to do those types of conditionals, why didn't they just use double ampersand? And the thing I heard from one of the people on the Microsoft team is it essentially becomes impossible to figure out if you have double ampersand there, where the ands actually get applied in some more complicated scenarios. So this makes it explicit. So you can use and or if you want. I can just fall down to the default case, which is if it doesn't hit any of these cases, then it gives you back an impossible. Okay, so that's one thing that's been added to pattern matching. You'll also notice with object nullability here, there's a couple different ways to see if something is null or not null. I would suggest from C#9 and on to use this technique because you're literally saying, is this literally null? If you do a not equals or an equals, it's actually going to compare using the equals that's within that object. And for the vast majority of cases, it's going to work as expected, but somebody may override it and do nefarious things. This is not ever going to fail. If it's not null, you're fine. So use is null or is not null from this point on to do your checks, okay? And the last thing I want to do, skip over the get enumerator extensions here, is source generators. Source generators is, it's hard to really say, is it a C#9 feature? It's definitely a feature that requires a version of the compiler that allows you to do source generation. So that's essentially the latest one that comes with C#9. But you're not limited to just generating C#9 code. Essentially what a source generator does is it says, I want to look for conditions within my code, and based on what I see, I want to generate more code. So you can think of it as sort of a templating engine. You can't change code. You can't say, based on what I see here, I want to go into this method and take out half of the method body, or change it so that it's rewired and I'm going to put some extra stuff in there, maybe some logging stuff. That doesn't work. Okay, it's only additive for now. But even with that, there are some, I have seen people do some amazingly cool things already with source generators. And I want to give you a demo of one that I just created that is essentially object mapping. Now, if you have ever used Automapper, which most people, if they think of object mapping in C#, that's the first thing they go to is Automapper, and it does exactly what it's intended to do. But anything that tries to do object mapping, especially if they want to be flexible, they kind of have to do things where they're going to use reflection at some point because they're going to check these things at runtime. Well, with this Inline Mapper tool that I wrote, and again, this is simplistic. This isn't meant to replace Automapper in any way, shape, or form. It's mostly to show you what you can do with source generators. Is you can create a generator class, which has this attribute and inherits from iSourceGenerator. And then based on things that you're looking for in code, I want to actually generate mapping code so that I can take a source and a destination and say, I want to create a new destination object based on values that are in whatever source is given to me. Okay. So in my case, what I'm doing here when my generator executes is that I am actually going to generate, I'm going to look for classes that have an attribute on them to say, I want to map to this destination type. And then for all those cases, what I'm going to do is essentially, if you start looking at this, you can see where I'm generating code within it. Okay. I'm going to start generating these map to extensions where I have an extension method map to whatever the destination name is. Okay. And then I'm going to go through all of the properties and essentially write out a source, a destination equals the source. And to make this simpler is if I go through an example here and I have a source type that has my map to attribute on it that says a map to type of destination, this map to method does not act, it doesn't exist on source. Okay. But if I have 12 on it, that's the generated code that's made. Okay. And in fact, just to show you that there's, well, it may feel magical, but if I come into source here and if I just put in a public int value, okay, get and set, and now if I take that and paste that into the destination, okay, you'll notice that now that popped up in the generated code as well because it picks that up and goes, oh, I need to regenerate. So now I have that mapping in place as well. Okay, so this is really powerful stuff. If I actually, is that the one that's running? Hopefully make that one the startup and run this. And we should see all the mapping properties happen, which they do. But what's also really cool about this is I can put a breakpoint on this one and say run. And I'm in release mode. Let's change to debug mode. Say close and run that again. Because it's C# code and it's put in with, it's literally within the same assembly, I can F11 here and step into the generated code and see exactly what it's going to do. Maybe it's giving me an error. Maybe it's throwing an exception. Well, now I can see everything I want to, and maybe I'll figure out what's wrong in my source generated code. Okay. Source generators are extremely powerful, and I highly recommend taking a look at them. So I'm almost done here. So we'll go into just a couple things for future directions. Now that everything is open source in C#, we can see kind of where things are headed, and we can also be we can make a direct impact on that ourselves as part of community members. This isn't just a closed source thing anymore. Okay. If you go to that link on the lower right for C# next features, this is the list that they have right now. This is not a commitment. This could change for whatever C# next would be. Who knows if that's 10 or whatever, or when that's actually going to happen. Apparently that'll happen in November, but they just call it C# next. So the reason I have generic attributes in bold there is because that's a feature I would really love to see, is having attributes that you can declare them as generic attributes. Okay. For any future directions, this link will talk about how they're now defining milestones and what features are looked at and where they're going to be put. There's a likely never, which is they'll keep that issue around or that idea, but it's probably never going to happen. If you look at the working set, that's what they have there right now. I would love for them to do that first one, type classes. It's complicated to talk about, but it would make the type system in C# very powerful, very extensible, and very flexible. So I'm hoping they do that at some point in the future. You can look at feature requests that have been made. You can make feature requests as well. You can actually even do them yourself, though, as you can imagine, doing a feature in C# is quite involved. It's a complicated process. And please don't just submit a PR with what you think is the most awesome feature in C# and just say, here, add this, because it will be rejected with a vengeance. They will not take it. That's not to say that they won't like the feature, but they have to make sure that it's something that adds a lot of value for C# developers. So don't be discouraged, though. You can at least say, I want to try, and they have an outline of how the processes you're going to want to have to take. And this can happen. You can light a fire to get a whole feature put in. Expression bodied members methods were introduced in C#, but they were only for methods. And some people said, why can't we do these for constructors? Why can't we do this in other places? And so the team just said, hey, we're going to make this expression bodied everywhere. And they said, we're going to have this so you can do this in anywhere in C#. And it was actually committed. It was actually added by community, not by the Microsoft team itself. So it can happen. All right, I'm pretty much at time. So I want to thank everybody for being a part of this conversation and for the questions. I really appreciate it. Wish I would have been there in person. Hopefully in the future that becomes a reality again. So if you got some questions, I'll try to answer those in chat here real quick. But again, thank you all for attending and have a good day.